Okay guys, let's have a go at question 11 then. We've got integral of e to the x sine x. I think of these as like a reflection or like a mirror. When you do this problem, you won't get an easier integral when you do by parts. You'll get an e to the x cos x probably, a multiple of. But that's like a mirrored reflection. It's the same level of difficulty, but it's e to the x cos x. And then if you reapply the same process, you'll get back to e to the x sine x. And then, so like a mirror of a mirror, it takes you back to the original image in a sense. So basically, if we do that and then we tie it all together, then we can find the solution. So that's the general approach when we see problems that look vaguely similar to this. Okay, so let's just do that without further ado then. That will be v, and that will be du. Draw our grid. Yeah. And v was equal to e to the x. Du is sine x. So dv will equal e to the x, won't it? And u will equal minus cos x. Okay, let's let that be I. So I equals then, it'll be uv, so that's minus at the front e to the x cos x, minus the integral of u dv. So there's a minus there, I can make that a plus, and that'll be e to the x cos x, won't it? dx. So now this is the integral I was talking about. It's the same level of difficulty as the original one, but let's reapply the same process to this. So let's let that be v and that be du. Circle that, call that j. So we're going to do this sub-problem now, e to the x, integral of e to the x cos x. So let's draw a line across the page and write j equals then. So v du, so we need to draw our grid for this sub-problem. V will equal e to the x. Du is equal to cos x this time. So dv will equal e to the x, won't it? And u will equal sine x. Okay, so let's put the pieces in the jigsaw then. It's uv e to the x sine x minus the integral of u dv. So that's e to the x sine x dx. Okay, that's back to our original integral. So we can draw a line off the page and we should be able to tie everything together. So I equals then, what have we got? We've got minus e to the x cos x, yeah? Plus j, and j, so put a bracket around it because we're going to put plus j in now. That's e to the x sine x minus, and this thing here is I. That's what we started out with, so we can put it in. So expand that bracket then. Minus e to the x cos x plus e to the x sine x minus I. Move the I over to be with the other I to make 2i. And shall we write that one first? So it's e to the x bracket sine x. Take the e to the x outside the bracket minus the cos x, yeah? Now the last thing then, I equals, so it'll be e to the x over 2 sine x in a bracket minus cosine x. Now we need to put a plus k in, so let's put a plus k here, plus k there, plus k there, but now we're divided by 2, I better write a plus k dash there, just to note the constant of integration, because you've divided that line by 2, haven't you? Okay then, so that's the final answer then. The integral is e to the x over 2 brackets sine x minus cos x, bracket plus k dashed, constant of integration. So did you see that, the reflection idea with the e to the x sine x? Whenever something looks like this in form, then you generally you don't step down a series of steps as we did in previous integration by parts. You just think of it as like a reflection, and then a reflection of a reflection, and piece it together. Notice this was v du, and notice we put this as v du. Had we done it the other way around, you'd have just basically been undoing what we had just done, and you'd get 0 equals 0 or something. So that's the important point as well, that needs to be in the same arrangement, yeah? And proceed through to get the final answer. Okay then, that's question 11 done. Good. Let's go on to the next one.